Okay, this is the first video about electrostatics in AP Physics C, and this is going to be a review of electric charge. Things you should remember from last year. Electric charge comes in two kinds, positive and negative. Generally, the most common positively charged particle is the proton, which is fixed at the center of the atom, and electrons, which are negative, and they are zooming around the outside, and the typical picture of an atom looks like something like that. The charge on the electron is negative 1.6 times 10 to the negative 19 coulombs. Charge on the proton is positive of that, and we usually call this the fundamental charge. Now, because the protons are stuck in the nucleus, they can't move around. The electrons can leave this atom to make an ion, and that means that when anything acquires a negative charge, it means it has extra electrons, and if it has a positive charge, it means it has lost some electrons and now has more protons than it does electrons. But generally, protons do not move. Now, there's also the difference between conductors and insulators, which you should also remember. A conductor allows electrons, or charges in general, to move freely. And an insulator does not. So you need to know protons, electrons, fundamental charge, positive, negative, and conductors and insulators. Now, when you have negative charge, that means you have a few excess electrons, and a positive charge, you have a deficiency in electrons, rather than you've added more protons. Now, let's say you have a conductor, and that conductor has some excess charge on it. So some randomly shaped bit of metal, and you put some extra electrons on it. What's going to happen is that those electrons repel each other, with the result that they'll try to get as far away from each other as possible, and all of the excess charge will lie on the surface. An insulator, on the other hand, because the electrons are not free to move, if you put a charge on one part of the conductor, that charge will stay on on one part of an insulator, that charge will stay on that part of the insulator. Conductor, you put a few extra electrons on it, and they'll all go off in every direction. And another feature of conductors is something called polarization. Like, for instance, let's say that we have a metal sphere, so it's a conductor, and it's neutral, it has no excess charge. Let's say we put some other positively charged object nearby it, but not touching it. What's going to happen is that the electrons in the metal will be attracted toward this positive charge, and because they're free to move, they're going to move toward it. And so you'll have some negative charge showing up on the side of the conductor that is toward the other charge. And those electrons had to come from somewhere, and so the result is that you'll have a positive charge on the other side. The overall charge on the metal is still neutral, but it's become polarized. The charge is separated. And because these electrons are attracted to this positive charge more strongly than the positive charge is repelled, because they're closer, there will be a stronger force this way, and the metal, even though it's neutral, will actually be attracted to the positive charge. Some insulators will also do this. Usually it's highly polar insulators like water. We'll do a demonstration in class of how water is attracted to an electric charge. But you need to be able to describe polarization. And now we need to discuss how you would put an excess charge on a material in the first place. Now, friction, basically this is when you rub two materials against each other and charge moves from one to the other. So an example of this is the balloon that you rub on your hair. In conduction, what happens is that you put a charged object in contact with a neutral object, and charge is shared between them. Not surprisingly from the name, this works much better with conductors than it does with insulators. So in conduction, if you've got two pieces of metal, you start off with, let's say, 8 positive charges on one and the other one is neutral. If you bring them into contact, what will happen is that you'll end up with 4 positive charges on each one. Well, not necessarily exactly equal. Depending on the sizes, it might not be equal, but the fact is that you have the same charge here as you do here. Now the last one, and the most complicated one, is charging by induction. In this one, you start off with, and induction only works for conductors, you start off with a neutral conductor. And you also start off with some positive charge, and that can be on a conductor or an insulator. And you bring that positive charge very close to this conductor. And it becomes polarized. Negative charges move to the near side, positive charges show up on the far side. Then what you do is you ground it. You connect a wire to the ground. The ground is basically an infinite source of electrons or an infinite drain for electrons. And when you do this, electrons will come up with a wire from the Earth because they want to get closer to the positive charge. And as a result of that, the positive charges basically go away because more electrons have come up from the ground. And then, after that happens, you cut the ground wire, so you disconnect it from the ground, and then you move the positive charge away. So you bring the charge nearby, you ground the thing you're trying to charge, then you disconnect the ground, and then you move the charge away. And notice that in this process, we have given this conductor a negative charge, which is opposite the charge that we started with, and induction generally does that. If you have a positive charge, you can use induction to put a negative charge on some other object. So what you need to know, the two different kinds of charge, the difference between conductors and insulators, what the term polarization means, and the 3 methods of charging. I'll be checking in class tomorrow, questions 8 through 10.